I've done is I've actually gone and I've got about a page of content there. There's a whole lot of Go programs then that I actually have in the directory with it. All of this stuff I'll actually put up on GitHub. So what we might do is we'll just write it down on the board and you can take a picture afterwards. Okay. So I kind of start off with context. So the other thing is keep stopping me and actually asking questions as we go rather than me ranting on. Okay. So the kind of outline I hope to go through is give it the context, who's using it, installation instructions on Ubuntu and Windows maybe, kind of my dev environment, some tips, some Go tools, highlights, some funny things, code samples, resources. So that's what I'm thinking of actually doing. Now how much of this I can actually get through I'm not actually sure, but we're going for about an hour, is it? And then we'll see.
Yeah.
So the context is, have any of you actually used Go already? Okay. So Go it's a language that's it came out of Google, and as far as I know, it's originated to be a kind of systems programming language because they were actually having trouble with build times with C++. We're only after just starting. So they were having trouble with build times, and they were actually investigating what they could actually do with languages, and they actually came up with this language. So the kind of people that were involved in it that are of interest are Rob Pike seems to be the main guy, and he's the kind of Unix guy that's involved in a lot of operating systems and languages before this. Ken Thompson, he's one of the Unix guys involved, Ken Thompson and Dennis Ritchie. And he's been involved in C and was involved in a language called B, which is a predecessor to C. So just kind of background. And then there's this guy called Brad Fitzpatrick. And if you know of a thing called Memcache, he's the guy that actually wrote that. He's an awful lot younger now than the other guys, and he's done an awful lot of work on this project called Camel Store, which he has actually used to put an awful lot of content into the standard library. So that's where a lot of that content is actually coming from. So as I said, they were actually having trouble with really slow build times with C++, C projects there. So it actually compiles and builds into a single executable. So you can actually pick it up, you can compile, build, and if you do it for the right operating system, the architecture, you should be able to pick that up and actually run it on a similar or a machine with the same operating system and architecture without any other dependencies with it. Now, there are qualifications to that, but generally that's what you can actually get away with. It is a procedural language. It's statically typed with syntax derived from C. It does include garbage collection, type safety, and some dynamic capabilities. It does not actually have this idea of type inheritance. Nothing that doesn't actually exist at all. No operating or no method or operator overloading, no pointer arithmetic, and no generic programming. The thing there is there are actually pointers in it, but they are not actually the same as pointers as you would use in C. And that's what the pointer arithmetic is about. The big thing I suppose would go is people are actually finding that they can actually use it for solving concurrency type problems. And the way it actually does that is that it uses this thing called communicating sequential processes, which is some idea from Tony Hoare, who's a big computer scientist guy from years and years ago. So there is actually a paper, and out of that he takes things like Go routines come from that, and channels. So Go routines they're a bit like in Erlang, the way we have processes in Erlang. So what you actually have in Go is you have this idea of Go routines. And Go routines they're not like a one-for-one with an operating system. but they are threads of execution that the Go runtime will actually manage for you. So you can think of them as threads of execution, just like in actors who actually have to process, which is a thread of execution. Channels then are a way to actually communicate between those Go routines, so you can actually use channels to actually pass data between them. And they can be a synchronization mechanism in that they can be blocking. So channels are by default, usually if you're constructing them, you indicate whether they're buffered or non-buffered. If they're non-buffered, non-buffered is actually there can be nothing on the channel. As in, when you go to send a piece of data into the channel, you're going to block until something at the other side receives off the channel. When you receive off the channel, the producer or the guy that's actually sending into the channel can actually continue. They will be blocked before that. Right.
I have a question there on the compile or the build into a single executable.
Do you want to give me 1 second now? We'll actually go to the end of this and then we'll actually do the questions. Because that's only going to be pointing out a couple of things. So it is available for most of the Unixes. So your OS X, BSD, Linux, Solaris, all that carry on. And it is available for Windows as well, which I'll come back to after maybe your question, because that's kind of interesting. And they did expect that a lot of C type people would actually get interested in it, but it turns out an awful lot of Ruby and Python people actually have become very interested in this. And I think it's because of speed and possibly problems with Go interpreter locks and trading issues in Ruby and Python. And the last point then is this talk or tech radar thing that comes out does it come out twice a year, is it?
Yeah.
Twice a year.
Yeah. So that thing actually has, and there's a one just released now, July 2014, that has Go as in the adapt section for languages. Not that that means anything, but no question.
So on the compile and build it into single executable, so thinking of like .NET or even Java, so you come along and you actually need to use, say, a third-party library, or even if you're using something in .NET itself. So you reference that DLL, okay? So it comes along then, and when you're actually deploying that stuff, that DLL goes along with it. So, but you're saying that's not the way Go works at all.
No. So you're saying third-party software or software that's in things that we would think of as libraries.
Yeah.
In C#. So those dependencies, they are there. So you actually pull them down, you actually have them on your local machine. And when you actually go to build your content, right, what you're going to get at the end of that is a single executable. Right? That executable has actually compiled the dependencies. It has actually compiled your main program. It has actually linked all that content together, and it actually gives you a single executable which includes anything that's needed to run Go and all those dependencies that you're actually using and your own software. So it's all in a single executable.
Right.
Now, the thing is, that sounds like C++ doing compiling and linking. The thing that Go does to actually kind of address the really slow part of that is, as far as I know, it's kind of smart about detecting that this has been compiled, it hasn't actually changed, so now we can actually go straight to actually using that when we did the linking.
Right.
As far as I know, that's the kind of stuff it's actually doing to actually do really fast builds, and that really fast builds is a big feature that Rob Pike and the people from Google actually go on about. Maybe one other thing as well to actually go back to is the Windows thing is actually interesting because it is an open source language in that the content is actually up in Google Code. There are contributors to it outside of Google. Windows, the Google people did nothing for Windows. As in that wasn't in their plans at all. But people actually stepped in and liked it, and they've actually come along and made sure that it actually works in Windows. And when, just recently, only a month or two ago or something like that, there was a release of it, which is it one? So 1.3, right, when that was actually released, as that was released, it was actually available for Windows and Unixes at the same time. But that was actually a community effort, as in people stepped in and said, we like this, we're going to make sure that it actually works with Windows, and that's actually inside of the source then. So there's all this files for Windows platform specific stuff that are actually inside there.
So when you want to deploy something to a server, so you build it and you just take that exe and that's it. There's no deploy or there's no installation like of a framework.
Or a CLR,
yeah.
no. But that was something I was actually telling you, that's actually something, I don't know if you've seen it, that Microsoft are actually looking at trying to do they're doing this thing now where you can deploy the CLR, a subset of the CLR for like Windows.
That's the Roslyn
web server.
stuff.
It's based on that, but actually doing it where you can actually deploy a piece of the CLR or subset of it for this web application type stuff. Not for things like WPF and that, you can deploy that side by side. There are videos on TechEd that you might be interested in. That Scott Hansen then actually goes on about that. And that's where...
That's the VNext stuff, not the MVC6, the VNext stuff, so...
Yeah, it might be after that. But it is kind of building on the Roslyn compiler and being able to take subsets of it. I think Go as well is kind of smart enough that the size of the executable you deploy will be bigger now. This is something, as far as I know, Mono had as well, that with Mono you could do a build and you can actually include the Mono runtime, give me everything in one piece of one executable that I can actually run. Another thing you talked about there was the dependencies. There is no dynamic loading of code in Go. Everything is in there. So you can't do things like plugins loading. You can't do that in the process. You can do things like make a shell out, open up another process, run something, and communicate with that. So you cannot actually do DLL or shared library type stuff, which I think I can actually show you. Any other questions?
What's one of the big attractions for me was the deployability of it. But the language itself is the main thing, the Go routines or, say...
Yeah, we've come to those, but
yeah, right.
we'll be coming to. Maybe one other thing to be clear as well there. Just because when you build, right, you build on an operating system and an architecture. It has detected that, right? You can take that executable and then you can go over to a machine that has the same operating system and architecture and you can run it. But you can't build on a Linux 64-bit thingy and expect to actually go over to Windows and actually run it. You can pull the source down, you can do a build on your Windows box and you can run it in Windows. There is another thing you can actually do as well, is you can compile Go, you can get it from source and you can do this cross-compilation stuff. Which means you can, on a Linux box or a Windows box, you can actually target the different operating systems and architectures. So you can do that. Now, I don't see an awful lot of people, I don't see doing this, but I'm sure people are. So you can come along on your Linux box and actually do a build, and that build, the binary that pops out, you can actually use that in Windows. And there are links for that. If you look for cross-compilation, you'll find it. So who's using it? Google are using it for parts of YouTube, some download parts of it. I don't quite understand. I don't think Google talk an awful lot about how they're actually using it internally or how much they are actually using it. Docker is the big one. That's the one where kind of I became familiar with it. So, do you know Docker? You know Docker, yeah. So Docker is actually written in Go. They came along. They had stuff written in Python or something, and then they decided when they were restarting that they do it in Go. So that's a pretty big one. Dropbox, Cloudflare, SoundCloud, BBC. In other words, lots of people are actually using it. Lots of people. There's lots more using Java and everything else. It's still small. But some significant people are actually using it. Right, installations. Is it alright the size of this thing? Because if I make it bigger, it'll actually go out, they'll do wraps and I won't be able to read it. Okay. So the installation right, what I'll do is I'll just kind of describe what you do to install it. So you go up, grab the tarball, grab it, bring it down, or a zip file for Windows, extract it, it's on your box. Now just put it on the pad and you're away, you're running.
No different to Java?
Java, yeah, I suppose, yeah, the way you can have multiple GREs on your box, yeah. Now, if you do that, you probably want to actually put it on your pad so that you can actually run, you know, you go version, I did it there, that it'll actually find it. There are some other environment variables if we get to things like workspaces. So you can install multiple versions, and so I'm just going here, which Go, that will give you the path to it, because I'm doing that in Ubuntu. And if you're on Windows, that won't obviously work, which won't. Go version and go in. So Go version will actually give you the version, we just seen that. And go in will actually come along and go give you information about the environment. Remember I talked about architectures and OS stuff. You'll see them there. Those are kind of things, they're environment variables that you can actually override yourself. Okay, so if you're doing, that's actually after detecting. But if you set the environment variable, it'll actually pick it up and use it instead of whatever the default values are. Okay?
So when you download the tarball,
Yeah.
the tarball isn't for a specific architecture and stuff, it's for anything, it detects that stuff.
Well, obviously you
But there would be a tarball for Linux or whatever it is.
yeah, but all if you do that, I don't know really. I do know that obviously you're going to get tar.gz or something for your Unixes, and you will get a .zip for your Windows. I presume they're slightly different, the builds of them. So workspaces. There's an environmental variable then where it they direct you to set up these things called workspaces. Now we don't need to actually do that for the things we're actually doing here, but workspaces are kind of important for things like getting software, pulling it down from Google, GitHub, Bazaar, all those Bitbucket, all of those people. And the idea is that you can actually set this workspace and environment variable, and that's the root. And within that, you'll actually have source. And then you'll actually, when you do installs and you build stuff, you'll end up creating content inside in two folders. One called package, which is for your non-binaries, and one folder called bin, which is where your executables will actually get created. Now, I don't think there's much point in actually going into that here because we won't actually need it. And could be a big enough topic. You can actually have multiple workspaces, and there can be problems with pulling dependencies if you've got multiples. So what they're saying is to actually to have one of those. I don't think there's any point in going into that detail. My dev environments, just to kind of give you an idea of what I'm actually doing here. So I'm not using an IDE. There is this IDE called Light IDE. I don't hear a whole lot of people talking about IDEs. I'm using Vim, and then I've got some plugins inside there for doing same things, highlighting. And then there's this thing called Go format, right? So in Go, if you look at Go code, they like it to be formatted in a particular way. You can run this tool called Go. Obviously, Go is a bit like Docker. Git. Go is an executable, and then you have sub-commands within it. So like in Git add, Git commit, Git merge, Git this. So Git is the executable, and then there's these sub-commands. So one of the sub-commands in Go is format. Actually, there's a bunch of them down here. And that format thing will actually take your code and turn it into their kind of format, which is just spacing and all of that. So the thing is there, just stick with their format. So I've got a bin tool, or plug-in to actually do that.
But you have to stick with our format. You know, like Python, you have to be.
No.
So it's not like Python.
No, but there are actually some pretty funny rules in it, and you're going to actually see that where you place braces is actually really important. But if you want to actually have 73 spaces between the end of the condition and the brace, you can do that. If you run it through Go format, it'll actually tidy it up for you. It won't do everything, but it'll actually do a certain amount of it. So you can do whatever you like, but you're going to find the compiler complaining about certain things like, I don't know, with Python, you don't have it, it's at runtime, you actually get that thing about the white space. Right, you don't have a REPL. There's no REPL. So it's not like Ruby or C# is getting a REPL. There's no REPL there. Okay. So what you can actually do is there's this thing called Go Playground, which is you can visit a website, you can put your code inside there, and you can go run that, which we'll show in a while. And if you run that, that's your way of actually seeing that things are actually okay, trying to do it fast, figure out how do you get the length of the string, how do you reverse it, those kind of things, rather than actually having to do it. Well, you can do that if you want to. Now that Go Playground thing allows you to actually go share that as well. It's like a clipboard, so you can actually go share, it gives you a permanent URL, and you can share that with people. So if you're having trouble, you'll see people actually going, look at this, go to this URL and you'll see my code.
I presume there was a reason, so why they didn't want to do a REPL?
I suppose if you think about it, it started out being this kind of systems language. There's an awful lot as well in Go. I think you will actually find that they go, nah, we're not putting it in, which I think I've listed in a while. They do. There's a lot of an awful lot of stuff you will actually go, I would have thought that'd be in there. No, it isn't. They're pretty slow about putting stuff in. They know what they want to do, and they won't put the stuff in a hurry.
You're saying things like classes and stuff like that.
Well, we'll come to that. Well, they're not actually putting things in. Those are very, very specific design decisions. I'm saying there's things that you might have expected. You might expect a REPL in kind of newer languages. So go to Clojure, you've got a REPL. Go to C#, we're getting a REPL. I don't know if you've Java 8 is. They haven't done anything about having REPLs.
Not that I know.
Right. The next, another thing is when you're actually searching, if you search for Go, you'll find nothing. So you need to search for Golang. So everything is kind of tagged with Golang instead of Go. And then the Go standard library source code, right? So I've actually found that that code, the standard library, that's actually pretty easy to actually read. And you'll find sometimes it's actually some of the best ways of actually, they keep telling you, read the way we've actually done in the standard library. And that way you'll actually learn how to write Go code, what their styles are, how they actually do this stuff. I've also found when you're actually trying to figure out how things worked, so I was looking at logging and actually trying to go, how is this logging actually going or working? If you actually just go and pull down the source, right, which is actually at Google, pull it down or cd into the package line or into the package directory and do greps, you will actually find your content. You'll also find that if you go to the website for the thing, there's a thing that actually goes the standard library, lists all the stuff, and if you visit that, you're visiting the same stuff as here. Now, we talked about dependencies as well. So if you've got dependencies on some libraries or code that you want to actually use, you'll find that that's up on GitHub, it's on your local disk, it's on Bazaar, it's on Bitbucket, Google Code, all of these things. And the way you can actually do regular, pull downs yourself and manage it all yourself with whatever the source control tool is. or you can use this Go Get to actually pull them down. And Go Get is going to actually have to detect what source control is actually being used, and it is going to actually assume that those tools are actually available. So you're going to find that the big ones are you're going to find you have to have Git and you have to have Mercurial on your box. Okay. You will need Mercurial because an awful lot of the content on Google Code is going to be in Mercurial. I don't know, I think they do Git stuff as well now. And GitHub, everything is obviously Git. So that's where the code for Go is. And if you pull that down and it's the -u released, it's like a tag or a branch or something, so that you're not actually at head. And you can actually look inside of the packages. Okay? And the grep thing is then for just finding the stuff. Okay? So as we talked about before, the Go-To, there's like these commands inside in the version you've seen. Get is for going out and getting stuff from source control somewhere, GitHub, wherever. Build is for building the stuff locally. Run, test, format, they're kind of obvious enough. I think hopefully we'll get to see these soon. Okay. So, right. So now, this is the part you were actually asking about, Billy, the kind of the high, or the stuff in the language. So there's this idea of packages. Packages are just like namespaces and your idea of libraries. Okay? And what I've kind of seen is there's two kinds of packages ultimately, are that you get two kinds of results. You actually get something that's an executable, right? And the way it knows that is the package name always actually has to be package name. Okay? And everything else is just something that can be linked in, a dependency. So you can't run something that isn't an executable. So when you're creating some piece of software, you're going to actually have to create an executable. So your package is going to actually start with, it's going to, like a namespace, it's going to be package name. Okay? So you end up with executables out of that. One binary. As I said, everything gets compiled and linked into that single binary, or that single executable. The third-party stuff, we kind of touched on it before, to pull down that stuff, you're going to actually have to have source control locally. So you're going to end up probably needing Git and Mercurial to actually pull the content. Yeah?
Would they not have, like if you were building your own package, say,
Yeah.
you wouldn't do Go
No,
Get.
you don't need that,
So would you not do the same for the Go Get stuff, as in
Yeah.
pull it down at a moment in time?
You don't need to Go Get it all, do it yourself. And there are advantages to that, because Go Get actually just pulls from ahead.
Yeah.
There is this kind of funny rule then about a version of Go. If it finds a branch that actually matches that, you can kind of nearly ignore that. It actually pulls from head. It gives you the master on Git. And very often, if that keeps updating, how do you keep tracking of it? Or keep track of it, or make sure that it's only the one I decide I want to actually use. And that's a kind of problem with dependencies. So they have this thing, a whole lot of people are doing this vendoring, which is where they manage the versions of it. Now the way you talked about doing it is perfect. It gives you the same result, that you will manage it entirely yourself. If your content is assigned in Git, though, you're probably looking at a sub-module there. You're going to actually have a Git repository inside the Git repository. You can do that with Git sub-modules. But you control the version.
Yeah.
It's entirely up to you to decide, when you're going to update it, you get to look at it, whereas Go Get is actually a bit clumsy, and people actually are doing stuff to try and address it. That's one of the weaknesses I actually have down here in funny, in that there's a bunch of people writing libraries to do it and figuring it out, and there is no kind of clear winner. They do talk about vendoring. That Brad Fitzpatrick kind of goes, would you run code that you just download off the internet? You have to know the code, the libraries that are inside in your code. This is the kind of daft stuff that you actually see with with you know, ruby gems and that, where people are pulling stuff left, right and centre and don't have a clue what's inside their code. You want to know your libraries or your dependencies.
It's kind of like the chef cookbook stuff as well. If that you want to, if you need to use, yeah, if you need to use a dependency on another cookbook, you'll go off and get that, and that goes off as well to get it pulls off other ones. So it's the same kind of thing.
Does it depend on the culture of the person at hand? Like, you know, if you know, when I think of the Ruby guys that pull down this, that, and the other, I often think of the guy that's in the back room just kind of trying to knock something together and make a few quid. You know, you know. Whereas I see your point about knowing
That's
your
a whole
libraries.
other discussion that if we could have an evening on that. But the guy in Google, the Brad Fitzpatrick, he makes the point. If you have a dependency in software, you still want to know what's actually going on in that. You want to know where it came from, and you want to know what the updates in it. You don't just blindly actually go pull it every time there's an update. An update, or whoever is managing that decides that any lunatic can actually go in and start contributing to the project, and you go pull the content. I don't think so. Right. So, highlighting testing. I have no idea why I put testing inside there, because testing is everywhere. So there is a testing story. There are no classes. We'll come to the code. It is probably going to go into another hour. But so the easiest thing is, or you'll see that there are no classes, and then how it actually addresses that. There are structs, like your C structs. There are functions. I'm kind of skipping down through these because I think it's easier possibly to show them in these programs I have that are kind of like 20 lines, and I think they are easier to actually look at and talk about. So there are functions. Functions just stand on their own like a functional language. There are methods, and methods are actually functions that are actually attached to a struct, which we'll actually see in a while. So that ends up kind of addressing some of the stuff you get with a class. Looping, there are no do whiles, fors, a bunch of different ways of doing looping. There's one way of doing looping using for. So you can actually use it in a couple of different ways, and it ends up giving you back to your looping. Slices, arrays, and maps. There's very little, there are no other collection types inside the standard library. So you don't get things like sets. So some of the collection types we would be actually used to, you may have to actually implement yourself. Right? So arrays and maps are pretty straightforward. Maps are just dictionaries, hash tables. Arrays are arrays as we know them. Slices are actually kind of different thing, and slices are actually used an awful lot in it. So slices are kind of like dynamic collections that are backed by an array that will actually grow as you need it.
So they're like a list.
Huh?
They're the same as a list.
As a list?
Yeah. List collection, as in they're backed by arrays and they can grow.
Yeah, they're not quite. They're closer to array lists as we think of them. Let's see, Sean.
Vector,
Not vectors. Vectors would be closer to vectors. Are actually a set size, aren't they?
No, they're dynamic in size.
Are they?
Yeah.
So slices, I won't talk an awful lot. I don't have any kind of stuff with the examples of those slices, but slices are actually really important thing. They turn up a lot.
So pre-allocate chunks, is that what
Yeah.
slices?
There's when you create them, you can actually say a capacity and a length.
Okay.
And then when they grow, they're going to actually do again are like what you call it, array lists, not they actually to increase themselves. An awful lot of the time you're backed by arrays. You come up to the end, you fill it, and now you've got to actually do and grow.
But do they grow in sizes that you specify, or do they grow as you add money on the end? Are they chunk?
No, I'd say chunked, yeah. If it was each time. But when you append to a slice, you actually get another thing back.
Okay.
It's a bit value types. So, yeah, sorry, if you're appending to it, obviously if you're changing it, it isn't. You're just changing the backing array, the slots in the array. Anyway, so slices. Error handling is just completely different altogether in that the functions are actually expected to actually go to give back an error, a bit like C stuff, where you check the result of each function call, which means you return whatever. Let's say the function actually is get the length of something, that it'll or open a file. Open the file and give you a file handle back, but it'll also give you an error. So functions actually can have multiple return values, and you have to actually deal with that. You have to actually deal with the error then, or you can choose to actually ignore it. So they haven't they haven't said these things are exceptional at all. They've actually said these are a fact of life.
So this is similar to the error line, okay, from a return value type, people that comes back, that type of way.
Yeah, I'm not very familiar with it, but I've just seen that. Yeah.
In what you call it as well, the Scala, you can return something that has a left and a right, and the right can be an exception.
Yeah. So the idea here is that there is no throw that you or catch 10 stack frames up, that worries about an exception that happens when
Deal with it, it's normal.
you deal with it straight.
I think there may be things that can actually catch right up at the top.
Okay.
But the convention here is that when you do something, you actually indicate whether it was error, and you actually have to decide then, as the person calling it, what you want to actually do with that.
Okay.
You can choose to completely ignore it, or you can actually deal with it. So they're kind of going, these aren't exceptional, these are just error conditions.
They're a fact of life kind of thing.
But a little different to your thing, Billy, in that you can actually, a function can return 24 return values, and the error will be the last one. It isn't one or two. It's any number of them.
You could do the same in Scala, but you'd be doing it in a roundabout way.
So channels and goal routines. So as I said, channels and goal routines kind of come from that CSV stuff. And channels are actually strongly typed in that you actually say, I want a channel of people, or a type, a struct, person, or a channel of bools or whatever. And that means then you can actually send stuff into it, and you can receive off of it. Okay? And they do have this idea of buffered and non-buffered. So non-buffered is, it's going to be blocking. It's a synchronization point. Okay? If it's buffered, you can actually do things like you can actually say there's 5 slots, and as long as when you're sending, once the 5 slots haven't actually full, it'll go in and you're onwards. If you actually come along and you do it, nobody's receiving off of it, you will actually get blocked then when you try and add the 6th one.
So it's a blocking collection type.
Exactly. Blocking connection with a set capacity. In that you see how big it is.
Yeah.
It's not infinite. So channels, goal routines, and closures, just like in lots of languages. Okay? So those are the high level one things. I think it's probably easier to actually show those in the code samples. The funny kind of stuff is mutations. There's a mutation all over this. As in, you're coming along and if you come along, you create a package and you create a var on the package. Functions all over the place can change it. The structs are completely mutable. That's a thing that we have a bit of difficulty with. In that functional stuff is kind of said, it's not great. So that is funny, and it's kind of a hard thing to actually give up. Visibility, again the same kind of thing in that you can only really scope things at a package level, in that there's this idea of there's something that's actually private to the package, and the way you do that is it's in the first name of the, let's say it's a function, it's in the first character, if that's upper or lowercase. If it's upper, it's publicly available outside the package. If it's lower, it's within the package. But even if it's within the package, you can use everything can actually see it. So it's a bit like JavaScript in that it is this one global thing, or once you're inside the package, it's kind of global inside the package. Error handling, we touched on. Generics, no generics. People keep actually asking for it, but there are no. You cannot actually write generic functions. Yeah, so that's kind of a hard thing to give up as well.
What's the use case for generic to no classes?
Functions, that's it. You can maybe achieve it with interfaces. They may actually, it might be for those very reasons that they aren't in there. But people keep actually asking for it. People keep actually asking for it. Again,
Missing something which
again, you will be actually possibly asking me questions that I don't actually to think about. I don't have the answers to this because I've been playing with it for a while. But I do know a lot of people are actually asking for it. Keep actually asking for that, and they keep saying no, no, no. List comprehensions, your link stuff. I see when your man Rob Hyde is actually asked why he says, write it yourself. So they say write it yourself, which is that you write it yourself for your specific case.
Are you already talking about DSL type stuff then? Like, are you already, like, I suppose I'm looking at the stuff you're going through, and I don't see besides the deployment stuff, I don't see unless you've stuff with the Go routines that you're going to show up.
Yeah, that's actually huge.
So that's probably the jewel in the crown.
I think that's actually the really big thing, yeah. And the Ruby Python people have actually decided, look, this is speedy. Oh, sorry, one other thing is, when you kind of get used to it, it's pretty straightforward writing the code as well. It is easy enough to read. It's easy enough to read when you get used to it. You have to do a lot of the low stuff yourself, though. Right, package dependency, we talked about that, about you have to use tools for the rendering, so the versioning is something you have to deal with. You can use, there is no clear winner, there is a thing called GoDep for managing the dependencies. Dynamic code loading plugins, no, unless you shell out, do something in a different process. Language elements, kind of compared to closure, there's lots of lower level manipulation closure, which kind of looks an awful lot more elegant. Android, they are actually doing something to address this. So I said the kind of platforms are usually kind of servers and workstations, kind of your Macs, your Linuxes and your Windows on servers and workstations, not really for things like Android, which is kind of interesting because it is a global language. But they are actually talking about trying to do some Java, JVM, Go, interop stuff. I don't quite understand how it's working, but they are talking about that, and that might allow you to actually go access the Android development kit or whatever, however you do the stuff in Android. UI apps, not a whole lot of those. People are doing some OSS. Again, we've actually seen that when people kind of stand up and go, it's all shiny, it's brilliant, it's brilliant, it's brilliant. If people aren't actually kind of giving you some of the downsides, I think you can nearly dismiss the talks. They aren't actually, you want people to actually tell you some of the problems they've actually had with it. Right, go examples. Will we stop?
Yeah, it might be a bad time, 5 minutes, maybe stop.
And then what I have left is we'll start looking at some of the code. So all of this stuff then is on GitHub, we'll actually write it up there. So if we pause.
So back there, we'll play with 10 minutes, so 5 passes, 5 to 1.
Yeah.